Welcome back to Victory Garage. In the last episode, the team was able to spin up our very first physical motor prototype. Well, sort of.
We actually witnessed a stator being energized and a rotor moving a fraction of an inch. But eventually we got it to go all the way around and kind of more or less prove the theory that it could turn, that it didn't just completely burn up on the test bench.
That's still a long way from driving a vehicle down the road. But the guys are really excited to have this proof of concept and to continue working on it to make it smoother and certainly more powerful. And that means no more Dremels.
When you're building things by hand, like the gaps between things are way too big for the motor to perform properly.
You know, you have human error and problems that arise not because of anything but because it was two human beings doing that by their hands. And we thought, you know, okay, let's make this computerized. Let's have a simulation tool that builds the motors in a digital way.
So we began by modeling the motor that we had, and then basically just optimizing that to the next generation motor. So we were able to basically get the tolerances down to an acceptable level. So for that, you need to have a machine shop get involved. Then you need to have drawings, which mean you need to have CAD, and that requires a lot more detailed calculations. To be able to achieve all that stuff, that requires a lot more engineering work.
We were only two of us at that point, so we definitely needed more help. And
that made it time for us to hire a third person for the team.
And this third technical team member, he's really brilliant, and he comes with some really interesting qualifications.
We had an opportunity to bring someone else into the team. There's also a certain leap of faith here where you obviously want to keep salaries at a minimum when we're pre-commercial. So we're still spending money developing and testing. But I think every day that goes by, I become a little more confident that this is actually a very viable commercial enterprise.
We posted a job ad, basically describing the role that we needed. And I realized this job ad was really asking for a lot.
This particular person could really help us in the running of the testing.
It was a very multidisciplinary position requiring knowledge in electronics, mechanical aspects, thermal, manufacturing.
Prototyping of subsequent motors, maybe up to the rate of a couple per week.
Extremely broad.
All that while keeping one eye on how are we going to manufacture this thing once it goes into production.
And I knew that was going to be a really challenging person to find a fit for. And then I was really excited to get the application from Jack.
Yeah, we are rolling. All right, just give me a clap right in front of your face.
Just to do it?
Yep.
Hi, my name is Jack Campbell. I'm the Mechatronics EIT at Victory Advanced Technologies, and so my role within the company will be the development of the product and advancing our internal processes necessary for its design, manufacture, iteration, and the continuous improvement of the product. So.
He's a great guy. He's super smart, very, very quick with his digital design and CAD.
I think he had the CAD of the motor within a couple of days. It was insane. And another reason that we wanted to hire him is because he's got a 3D printer right in his bedroom.
I'm doing all of the early stage 3D printing for the project. I've been doing 3D printing for a number of years, and it's something that I'm quite passionate about. It's exciting to work during the day on a design, come home, get supper ready, put the design on the printer, and wake up in the morning and have all the hard work done for you and just peel the part off the print bed and take it in the next day to work.
That was one of the best things because that really accelerated our growth because we could iterate so much faster.
We were making design changes on the fly. Normally you go and you have to set it up to a machine shop and it comes in a few days. But Jack was basically at work, he would send the 3D print home and then would come to work the next day with a new part.
Wow, man, that looks awesome.
And that's a pretty awesome turnaround time.
With the guys designing new parts by day and Jack taking those designs to his 3D printer in his bedroom at night, it did not take long before the guys had everything that they needed for a second working prototype.
So Jack, can you explain what we're about to see here? What's going on with all this?
So this is the absolute fastest that we could wire 5-phase switching in. So it's a little bit unaesthetically appealing, but it is
We're also using 18 gauge wire, which is not what you probably should be using for this. Actually, it's definitely not what you should be using for this, but that's the best we can do.
Okay, all right.
The first time that we hooked up the motor, it was pretty nerve-wracking because we now had more criteria of what constituted a victory. Before, with the first motor, it was just the motor just had to do something, basically. Now we had a little more of an idea of basically the performance characteristics of the motor, and we had a bunch of tests that it needed to pass in order for us to be happy.
looks good.
We decided, probably foolishly, to do a live demo for the very first test. We had Steve and Greg in there at the time, and just as the motor was coming together, and we decided for the first test that they were going to get to see it. Right. So the pressure was on.
Oh, something's smoking.
A little bit of smoke there.
It worked okay.
Jury's out on champagne.
You're not seeing what you wanted to see?
I'm
Smoke
and mirrors.
Well, we definitely got smoke.
It moved, but it was smoking. The wires were not the right size. The insulators were turned to bubble gum. A bunch of the switches were mislabeled, so we're firing it in the wrong order. It was a mess, but it turned. There was a whole lineup of different problems the motor still had that if we had have probably, taken the time to test it first before we demoed it to everybody, the test would have gone a lot better. But, we're trying to move fast. We're trying to, none of the things that we were doing represented safety concerns. So, we're happy to go and take some risks for speed when it doesn't really affect a safety concern.
There you go. Did it?
You're sweating there, Isaac.
I definitely am, yep.
The team needed some time to celebrate this great win, this great victory. But it didn't take long before Isaac was pulling us back into the test bench and really explaining to us what makes this motor so unique and so novel.
Safety first. 1, 2, 3, 4, 5. So we can just basically continue doing that until it turns fully. That's a really low.
Yeah, so it was like
motion.
maybe a 16th of a full rotation, or?
Exactly.
High torque, low speed.
Exactly, high torque, low speed, which is great for for getting off the line, or when you need a lot of torque. But the characteristics of this is it's going to limit your ability to operate the motor at a really high speed. Mm-hmm. So one of the things that we've done that's kind of neat is by having different switching methods, we can change the gear ratio of the motor. So we can do another way. 1, 3, 5. I think it is 2, 4, 2, 4, which changes the ratio pretty significantly. So that all of a sudden now you don't have as much torque, but the motor can operate at much higher speeds. So with software, you saw there's no gearbox there. We weren't shifting gears, no clutch, no nothing. Just purely by the way that we were switching this, we can change the torque speed characteristic of the motor, which is, I think, pretty neat. Also, the other kind of neat thing is that we can fire these at the same time in both gear ratios, so that we can get even more torque as well. So we sort of basically have, in a way, a 3-speed gearbox, but purely by software.
So there we go. With 2 working prototypes proving our motor's concept, it's time for us to take it to the next level, which is pitching to funders.
Personally, I kind of wanted to see it work before we invested too much time or asked anyone else to invest their time in this and/or money. So I think we're at that stage now where we have a lot of confidence that we are on the right track and that this is something that's going to become very, very real here momentarily. And what that means initially probably is collaboration with organizations like the National Research Council, NRC, which is a federal government agency that invests in Canadian research and development. I think Victory is ideally positioned to work with them going forward. So we've got to shift a little bit maybe from the engineering and product development, or some of us have to shift our focus from that over to technical writing and business plan assembly, and so we have a lot of work to do.
So we got busy making a presentation that proves the business case of our technology. And the technical team, they had a mission of their own, to build the next iteration of the motor at full scale.
Then the next phase after that is to build the first one that is, we'll say, car-sized, meaning it's got sufficient power to drive a car, like the one that's behind me now.